Hello, it's been quite some time since I did a video, and there's something that I really like to use in Visual Studio, probably my most used and most favorite feature, which isn't that crazy of a feature. So let's just jump into it. It's basically a way of being able to copy a block of code and tell it to move into another file. And I'll show you why it's super useful. I use it for designing code a lot. We're going to create a thing called a task schedule. All right, we'll just call it tasker. We don't need to make this too computer sciencey sounding. We're going to make a file in here to design out a class or a set of classes or interfaces for being able to schedule some tasks, and whenever the time is met, it'll execute the task. So I'll just create a thing called I'll call them a timed event, and I'll just make this an interface, an iTimed event. Okay, so one thing that I like to do is to be able to see all the things I'm doing. If you imagine that on other things that you do, let's say that you've planned out something, you usually stick your entire plan in front of your face so you can actually think about what you're doing and understand what you're doing. So that's what we're going to do. We're going to plan out our whole structure here in one file so that we can read it. So we have a timed event. And what is a timed event? Well, it's something that has, let's just say it has a date time. And that date time is going to just be when it executes. So I'll just call it time. That's good. Hold on, let me disable this Visual Assist plugin. Makes my colors all weird for C#. And we'll have it, you be able to get that time. So now we need a class to be able to have a whole list of these timed events and fire them off whenever they're ready. So let's make an interface for that first, because we may have different variants of this. I'll call it the event. I'll call it the task. The tasker. The iTasker. You can give these better names if you want to call them event schedule or whatever. But we're just keeping these simple. I like short names, and this is just a tutorial. I'm not trying to teach you. I'm not trying to be a dictionary or a thesaurus here. So we have an iTasker, and this iTasker internally has a list of timed events, or a dictionary of timed events, or whatever, some collection of timed events. So we don't need to expose that. What we do need to expose is a way of adding and possibly removing timed events. So we're going to have a void add. We're going to have our timed event here. We'll call it event, and we're going to say where t is iTimed event. Likewise, we'll have one for when we remove. And then we need something for executing. So we're going to have maybe an update or a checker or some kind of thing. We'll just call check, void check. And that will go through and fire off timed events. So we have a time for the event, but we also need to have some kind of execute function in here, now that I'm thinking about it, now that I'm looking back and forth. And it's possible that we want some context for this event, and so that this isn't just a blank execute. That way we don't have to stuff all the context directly into the class that implements this. So let's create a public interface and call iTimed event context. This will have just some information. Maybe you have a bunch of players or a bunch of robots or something, and you have an ID. We'll just call it player ID, and we know that's going to be going into our events. And of course, the classes that you implement this with can have as many fields as you want, and many properties and all of that. But we're going to keep it simple with one. So we're going to execute with iTimed event context. There we go. So now we have this, we can really see our design here. We can see that we have this guy, which uses this guy, which uses this guy. And we can even build out let's say a part of this class here, public class tasker is an iTasker. And I'm not just showing you the Visual Studio feature straight up front, because the most important part of it is understanding why this feature is useful. So we're just going to build out pretty quick and dirty. To get this menu, by the way, I just clicked on the red squiggly and hit Control Dot, and then you can just hit Enter to implement the interface. This will stub some stuff in here for you. I don't really need to fill these out. I will put this just so you can kind of see what I'm doing here. I'm going to do a list of I-timed events, and I try not to have null anywhere. It's inevitable in these languages that support null, but I always try to initialize to something. It's better to have, even if this was an array, I would set this to a new empty array. And I've looked at the IL code for doing this, and it looks like it assigns it to a constant, so it doesn't actually mess up or add any kind of extra memory from what I can tell. But if you did something like this, this is a good way to initialize an empty array as well, so that you're not having to check for null if you're using arrays. So there we go. We have our events set up. Of course, we're just going to make this simple. We're going to say events.add evt, and we're going to have the remove. I want that up here. Let's put that up here just because it's easier to see. And events.remove evt. And of course, our check is just going to be a simple, in this case, a simple for each loop, var e and events. And we're going to just say if this time, so if e.time is less than or equal to datetime dot, let's say we're using UTC time, then we're going to do e.execute, and we're going to pass in a context. And of course, this context can either be pulled from something, it could be passed in. Let's say that was passed in. So you see here that I came to a point where hey, I missed something. Maybe we need to pass the context into the check as well, so that this context is coming from the outside world, and we can supply some extra fields in there if we need to, and we can execute on that context. So now we have a oops, I need to pass the, see, this is another thing, like I don't have to swap between files. I see it all here. Forgot to pass the context into my timed event. There we go. So now we have this whole setup. We have this tasker. You can very easily unit test this. And we have these three interfaces. Now, this is kind of annoying because they're all in one file. And here's the key to this entire video, 8 minutes in, is that we want them in their own files. Let's say that we've solidified this design and we're done. So let's go ahead and make it so that they're in their own files. I'm done with all of this, so I'm just going to say, you know what, this class here, I'm going to highlight it. I'm going to hold down Control and press dot. And it's going to say right here, move is going to be the first option, move type to timed event context.cs. And when you do that, it actually finds all the using statements and it finds the namespace and everything. And right here, it creates the new file for you with all of the using statements and the namespace and all of the scoping that you need. So you can come through here and just press Control dot enter. Oops, maybe I did that too fast here. Control dot move to names. Oh, that's this one is in the iTimed event. I'm messing with the wrong one. So there you see, it doesn't just mess up if you do something silly like try to move the thing that's the interface of the class that the file is named after. But we can go do these other ones. So Control dot enter. Let's see. My keyboard is being a little slow here, but Control dot enter. Highlight this one. We do Control dot enter. And now they're all off in their own little classes or their own files here. I've solidified the design. Everything's good. I maybe made all the unit tests for these. I went and tested to just make sure that these feel right. But that's the most important thing to me, is to be able to design the code out in one single file so I can go back and forth and see things and see how they relate and wonder if I missed something or if I can remove something. and how they interact with each other, and then I can move them all into their own files. And this really, whenever I started doing this a few years ago, this really changed the game for me designing code, and it helps me create a lot less code, a lot more concise code, and a lot more testable code. And I highly suggest that you design your code this way. My favorite language is C, and though it doesn't have classes and all of that kind of stuff, I still use these kind of features to extract code. I build it out so I can see it, and then I extract things around to more manageable or readable or permanent places, because, as you know, you should follow solid principles, and one of those is the open-close principle. Once you write it, you don't want to mess with it again. And the best way to do that design is not just to use interfaces and pass in things so that you have some kind of visitor pattern or be able to modify it through external means, but also just being able to see all the code in one place and think about it, because your job as a programmer is to spend half of your time, if not more, thinking and not writing code. And then writing code is the remainder portion, and maybe 20% refactor. So thanks for watching. I hope this helps. This changed my life in coding, and it just really helped me focus and design things in a way that I'm happy with. And I hope it helps you. So see you guys next time.